Alright, second thing we're talking about today is properties of matter and physical versus chemical changes. So we'll just get started and go right through it. There shouldn't be any math involved with this one, so give me 1 second and I will turn off all of that stuff. Okay, so properties of matter. A property of matter, or a property, is basically just a descriptor of an object. Physical properties are things that you can either see, hear, taste, smell, touch. You can see them, you can observe them with your five senses, just by having the object physically near you. Some examples of those physical properties: color, smell, taste, hardness, all these things that you can tell about an object just by observing it. Alright, and a couple of things that you might have to manipulate it to find out. Like malleability means how flexible it is and how easy it is to bend it and change its shape. And then solubility is how easily it can dissolve and that kind of stuff. Alright, chemical properties aren't things that you can tell just by looking at it or feeling it. Chemical properties have to do with how it will react with other chemicals. So it's a lot of like flammability, whether it reacts with acids or bases and that kind of stuff. Air reactions are a big part of chemical properties. You don't want anything that's made out of iron to be sitting out in the humidity because it'll rust. Silver and copper will tarnish if they're left out uncovered for too long and stuff like that. Those are all examples of chemical properties. So here we've got a couple of slides of examples. I want you all to see if you can guess before I say it whether it's a physical or a chemical property. So here, the ability of gunpowder to burn and explode. That one's going to be a chemical property, right? Anything that describes flammability or how it reacts with heat or fire in order to combust is a chemical property, because combustion is a chemical reaction. All right, the color of an orange. Color is something you can observe with your sight, one of your five senses, so that's going to be a physical property. The ability of a nail to rust, we talked about that a minute ago. Rusting is a chemical change, so the ability or capability of something to rust is a chemical property. Wood burning, the ability of wood to burn, that's going to be a chemical property as well. Anything that has to do with flammability or burning or exploding, anything like that, is a chemical property. All right, the shape of a leaf. So shape is something you can see or feel, and it doesn't have to do with how it reacts with other chemicals around it. So that is a physical property. And then hardness of a diamond is also a physical property. Hardness is something you can feel, by squeezing it or trying to scrape it with something. It's a physical property. All right, stomach acid being able to break down food. That is a chemical property because it has to do with the acid in your stomach reacting with whatever it's trying to digest and breaking it down. Generally, if it has to do with a chemical reaction or a chemical change, which we'll talk about later, it's a chemical property. All right, and the mass of a camel, that's something you can observe with your five senses. Obviously you can't pick a camel up, but if you tried to, you would feel how heavy it is, right? And you can, anything that you're worried about mass is a physical property. All right, so now that we've covered properties, we're going to talk about physical and chemical changes. So a physical change is a change that occurs without changing the identity of the substance. So nothing new is formed, and usually physical changes can be reversed. You can turn them back the other way, but not always. Okay, so some examples. If I took a piece of paper and tore it in half, both halves of that paper are still paper. It didn't change what the paper was made out of, didn't make anything new, so that is a physical change. One thing that trips people up is phase changes, like melting ice or boiling water to turn it into water vapor. That's not making anything new. It's still water, it's just in a different state of matter. So it is a physical change. All right, that's one that gets people, so make sure you pay attention to that. Dissolving something in water, sugar or salt or anything else, is a physical change because it doesn't change the identity of the sugar. Having it dissolved in water doesn't make it not be sugar, right? It's still sweet if you drink it. Same with salt. And you can reverse it very easily by boiling the water away and getting the salt back. You didn't have to do a chemical reaction to reverse it because, like we just said, boiling water is a physical change. So you get rid of the water by boiling it and the sugar is still there, not any different than it was before. So dissolving is a physical change. And then painting a wall. You're changing the color of it. You're not making anything new. The paint is still paint. You know, the wall is still the same wall that it was before, just a different color. Physical changes. All right. Chemical changes, on the other hand, change the identity of the substance. They change it to something different. Usually a new substance is made when you do a chemical change, and a lot of times they're much, much harder to reverse. You can do it if you go back through chemical reactions for some chemical changes, but sometimes it's even impossible to undo. All right, so evidence of chemical changes. So these are signs that if these happen when you put two chemicals together, it's evidence that a chemical change is occurring. Color change is a big one. Bubbles or gas being produced. So like if you drop, or like you guys have all seen baking soda and vinegar, right? You mix them together and it makes a bunch of bubbles. That is evidence of a chemical change occurring. There's a reaction going on there. All right, if heat, light, or sound is made by a reaction, so anytime you have fire where it's making heat and light, that's a chemical change, a chemical reaction going on. And then one that you won't see often in the real world, but you might in chem lab, is if two liquids are mixed together and a solid is formed. So you pour two liquids together and a solid falls out. That's called a precipitate, and that is an example of a chemical change occurring. Okay, so some examples of a chemical change are acid-base reactions. So baking soda and vinegar, like we just talked about. If you pour vinegar, or if you guys have, like, if you drink tea, you're not supposed to add lemon juice and milk because the lemon juice can curdle the milk and make a reaction with it because it's acidic. So those are examples of chemical changes. Oxidation reactions. So iron rusting, that's a big deal down here. Everything rusts because it's humid all the time, right? So that is an example of a chemical change. Combustion, like I talked about earlier, anything burning is a chemical change, a chemical reaction. All right, and then reactions between two substances. So if you have sodium and chlorine and you mix them together, it'll create a flame, and they mix together and they make salt, sodium chloride, table salt, or silver reacting with sulfur in the air to tarnish and create that like pattern on the outside of silver, like spoons or anything like that you sometimes see. That is a chemical reaction as well. Okay, so you've got a quick homework assignment. I tried to make this video short since the first one today was so long. And the homework assignment should be pretty simple as well. I think it's only 10 questions. So good luck. If you have any questions, as always, let me know. I'll come help you out, or shoot me an email.